Okay, time for the big problem. Chapter 1 review, problem number 17. So they give us a pyramid and they have labeled the corners of the base and the top of it, and it is a square-based pyramid. Okay, so that gives us some things to work with. They also give us some information. They say AB is 16, and they give us the slant height AE right here. They tell us that AE, which is going to be the same as EC, so I'm just going to put it over here, that this is 20. So 20 centimeters and 16 centimeters. All right, so from that, we're going to be able to figure out a lot of stuff. So first of all, angle between AE and the base of the pyramid, the plane ABCD. So I was thinking about that, and I was like, well, where would I figure out this angle, because it's AE and then it's meeting the base, but I need the other side of the triangle. So I decided I'm going to just draw a diagonal across here. So I have this angle right here coming down AE and then going straight across the plane here. That is going to give me that angle to the base. So AE comes down and I'm going to go straight across right there. So the reason why I did that is because I can figure out this side right here, and I can use that to help me figure out this angle. Okay, I also know that I can drop my height down and it's going to meet that diagonal. So when I do that, I get a nice right triangle. Okay, so I'm forming a nice right triangle that I'm going to be able to use here. So from the top of the pyramid straight down to the middle of that base, and then over along that diagonal over to point A. Okay, so when I do that, I have, here's AE. It's coming down. Let's call this point, I'll give this point right here where the height comes down and meets the diagonal. I'll call that F. So I have A, E, and F right here, and it's going to be a right triangle. I know that AE is 20. That was given to me. And I know that this distance right here, I can figure that out. I can figure that out because this base is a square and it's 16 by 16, and I can figure out the diagonal because this must be a 45, 45, 90 triangle because it's an isosceles right triangle. I have a shortcut here. This is going to be 16 root 2. So I'm using my shortcut triangle that I learned in geometry. I could have done the Pythagorean theorem though as well, and I would have gotten the same thing, 16.2. So all the way across here is 16.2. So that means from here to here is going to be half of that. So half of that, which is my AF, half of 16 root 2 is going to be 8 root 2. Okay, and so now I can figure out the angle. I can figure out theta right here by using some trigonometry. So to this angle, this is the adjacent and the 20 is the hypotenuse. So cosine of theta is going to be equal to 8 root 2 over 20. So theta is going to be equal to inverse cosine of 8 root 2 over 20. And grab my calculator. And I'm going to do inverse cosine of 8 root 2 divided by 20. And that gets me 55.5. So that angle is equal to 55, what did I just say? 55.5 degrees. And there it is in 3 significant figures. I believe in the back of the book, they just rounded it off to the nearest degree. I don't know why. So that would be 56 degrees, gets you the answer in the back of the book. Okay, so that's part A. All right, moving on to part B. Calculate the angle between the plane face BCE. So BCE, that's this triangle right here. So now I'm going to be looking at that triangle and the angle that it makes with the base of the pyramid. So with the base of the pyramid. So I am going to, again, I want to make a right triangle. So I can make a right triangle if I just drop down the center of that triangle and then I go straight across to inside again, just like I did with this triangle over here, the AEF, I can put in a little triangle right there that goes to the center of the pyramid, goes up to the top of the pyramid, and then drops down along the side of that face. And I want to find this angle right here, right? Isn't that what I want? BCE, between the plane face, BCE. Yeah. Okay, so I'm going to find that angle in there. So for part B, okay, so this was all part A. Yeah, that was all part A. Not very organized. For part B, I'm going to take this little triangle in here. So E, F, A, B, C, D, E, F, G. So call that G. So I'm going to have E to F to G. And that's going to be a right triangle. And I can tell what this is going to be. This base of this triangle, see how it's parallel to this side right here, 16, and it's going halfway across. So I know this is going to be 8. I'm trying to find this angle, and I can figure out the height of the triangle. Did I do that yet? No, I haven't done that yet, but I can figure out the height of the triangle. Or I could figure out, I actually could figure out this also, because that's a right triangle. So there's a couple ways I could go here. Decisions. So the way that I did it is I actually figured out, I'm trying to look at my notes. What did I do? I figured out this side by using this triangle. Okay, so I figured out EF. I got EF from this triangle. What I did is I did the Pythagorean theorem. Okay, but I do actually have a few choices for how I can do that. So if I go back to my first triangle on part A, I can solve for this side. Okay, so we'll call this B. I can solve for B there by doing just Pythagorean theorem. Okay, so I can figure out this. This is going to be my B, length B. So I've got the hypotenuse squared is going to be equal to 8 root 2 squared plus b squared. Okay, and so then I'm going to solve that. So 20 squared minus 8 root 2 squared is going to be equal to b squared. So b is going to be equal to the square root of this. Notice the parentheses that I'm putting around that 8 root 2. You got to make sure you square the whole thing. Don't just square the 8 or the 2. You got to square the whole thing. Okay, so if I do that and put that into my handy dandy calculator, let's go ahead and do that. I'm going to have the square root of 20 squared minus parentheses 8 root 2 squared. And yep, that's it. Hit enter, and it gets me b is equal to approximately 16.5. All right, and that seems like a good number looking at these other numbers on my shape. So this side is going to be 16.5. This side is going to be 8. So I'm trying to find this angle. Let me draw this again. So I've just figured out the height, this direct height, the EF, is 16.5. I already know this has to be 8 because it's going to be half. Oh, sorry, you can't see what I'm doing. Because it's going to be half of the base, half of the side of the pyramid. And I'm trying to find this angle right here. Okay, so again, SOHCAHTOA, this is going to be tangent, and we'll call this alpha. So tangent of alpha is going to be opposite over adjacent. TOA, yep, opposite. Got to remind myself of these things, over adjacent. And so alpha is going to be equal to inverse tan of 16.5 over 8. Okay, so on my calculator, second tan 16.5. Well, actually, you know what? Let's put the whole thing in. 16.5 came from there, divided by 8. And that gets me 64. Alpha is equal to 64.1, approximately equal to, I rounded it off, 64.1. So that is the answer to B, 64.1. So then, yeah, that's it for B. Okay, so question C. Moving on. So that was question B. Question C, it asks for calculate the angle between the line AE and the line EC. Okay, so that's up at the top here. So AE comes up to the top and EC goes down from the top. So I have to think about this a bunch, but if you think about it, you could make a big giant triangle from A all the way up to E and all the way back down to C. You could do that. And yeah, actually there's a bunch of ways you could do this. So thinking about C, I could make this giant triangle here that goes from A up to E and back down to C. I have this, and then it goes across the diagonal there. So this would be the diagonal, that's 16 root 2. And then AE, this would be my 20, and this would also be 20. And we've already figured out the angle over here. This was our alpha. So my theta, that was 55.5. So this is 55.5. So this also has to be 55.5 because this is a very regular pyramid here. 55.5. So all I got to do is 180 minus 2 times 55.5. Let's see if that works out. I actually did it a different way when I originally did it, but let's see if I get the same answer. So 180, why did I put squared? That's degrees. Sorry about that. Okay, 180 minus 2 times 55.5. And I get 69, and the actual answer is supposed to be 68.8. So I got a slightly different answer. Okay, interesting. So the way that maybe because I shouldn't have used 55.5. Okay, let me go back and find it. 180 minus 2 times, it's actually this answer up here. And then let's see, there it is, 68.9. Okay, so that's the answer. If I use the whole answer, instead of just rounding it off to 55.5, if I take the whole original answer, then I get 68.9. Okay, so that's the answer to C. And the book had the wrong answer in it, but the corrections that I got from the publisher says that that is the correct answer, 68.9. So we're okay with that. All right, part D. This is where people started having a hard time. People were telling me, I couldn't get the right answer for D or E. So again, the book, actually, the publisher told me that the answers were a little bit off. So if you already did D and E and you just want to know the answers, D is 1407 is what the publisher is saying is the right answer. And I think I get that. I'll show you how I got it. And for E, the publisher said the answer was 843. And that is exactly what I got when I did it. So let me show you how I got D. So D, find the volume of the pyramid. Hey, there's got to be a formula for volume of a pyramid. So if we look over here, volume of a right pyramid is 1/3 area of the base times the height. And the height is measured right there in the center. So for number 6, volume is equal to 1/3 area of the base times the height. Okay, so 1/3, the area of the base is a square and the sides are both 16. So that's going to be 16 squared. And then the height of the triangle was EF. If I go back and look at that, the height of the triangle, of the pyramid is EF. And we found EF. EF was 16.5. So I'm going to put that in, 16.5. And if I toss that into my calculator, I get, turn on my calculator, I'm going to do the 16 squared times 16.5, and then I'm going to divide that by 3. And that gets me 1408. Oh, gave me exactly 1408. Interesting. 1408. Okay, probably because the 16.5 was kind of rounded off, right? That wasn't an exact answer. Okay, so 1408, which is what the publisher says should be the answer. Oh, they got 1407. Okay, so I must have rounded off that 16.5 too much. So if I go back and I find my 16.5, there it is. If I did that, so I'm going to do that times 16 squared divided by 3. That gets me 1407. which is what the publisher is saying is the correct answer. Okay, so if I use, which I should, the full answer for the height of the pyramid, I actually get 1407. And I think are we in centimeters? No, I've forgotten. Yep, centimeters. Cubed, because it's volume, centimeters cubed. All right, last one, part E. Gosh, have I been talking for an hour yet? Okay, the last part E, we want to find, where is it? Find the total surface area of the pyramid. Okay, so surface area of a pyramid is, well, you just need to find the area of each of the surfaces and add them together. So on the pyramid, okay, this was D. So here we go with E. We have the base, which is a square, 16 times 16. And then we got the sides, which are triangles. And we know that all the way across is 16. And did we find EG? No, we didn't find. Okay, I'm looking at here. We need to find the height of these triangles. We didn't do that yet. So we need to find EG is the height of these triangles. If I'm just getting the area of the triangles along the side, I need to know what EG is. So I have, what have I got here? I'm going to find this height. Okay, I know that the side here is 20. And if I cut this in half, I'm going to have a right triangle. And so the base of this right triangle, oops, sorry, I'm off the bottom, is going to be 8. And this is going to be 20. And then I'm going to find, I'll call this A. So A squared plus 8 squared has to equal 20 squared. So A squared is equal to 20 squared minus 8 squared. So A is going to be equal to the square root of 20 squared minus 8 squared. Throw that into my calculator. So square root of 20 squared minus 8 squared, and I get 18.33. Okay, so that is going to be the height of this triangle. So my area of the base is 16 squared. So my total surface area is going to be 16 squared. That's for the square base. And then I'm going to have 4 of these triangles. There's 4 of these triangles forming the pyramid. And it's going to be 1/2 the base times the height, which I just calculated was 18.33. All right, so let me put all this into my calculator and see if we can get the right answer. 16 squared plus 4 times 0.5 times 16 times, and then I'm going to grab that and close a bunch of parentheses. And I get 842.6, but with 3 significant figures, it would be 843, which is exactly what the publisher says it should be. And that's what I got when I did it the first time I did it. 843, and this is area, so it's going to be centimeters squared. Woo! And that was problem 17. Hope that helped out. Big part of the problem is just having the wrong answers in the back of the book, perhaps. Sorry about that.